Yeah, all right. So I'll just jump directly to share my screen and explaining what a pipeline and a column transformer is. So the concept of a pipeline is pretty straightforward. Pretty. If you know all about this plumbing, well, anything that has to do with um, creating a plumb line also, you have to create a pipe that actually connects from a bigger pipe, and then there's a distribution downward, and like that. So there's a bigger supply that spreads further into different sections of the building in order to ascertain a specific goal of serving as much people as possible. So the concept of a pipeline now, not in machine learning, but yeah, the whole concepts behind what this pipeline is doing in scikit-learn is that it tries to sort out the various processes of, I'm looking for my words now. It tries to sort out the various processes of cleaning the model and performing future engineering and all of this stuff in a progressive form. And what this means is that a pipeline takes the data, raw as it is, like this particular kind of data. All right, it takes, say, let me scroll to the edge here, and go to the top. So it takes, say, this particular kind of data, given the gender, the this, the that, it takes all of that, then it takes them directly into the pipeline. It's, for instance, this gender now, it encodes it in the pipeline. There's a session for encoding the gender. There's a session for encoding the married future here. There's a session for encoding the dependents, and it does this for all of the future columns. When it encodes it, either encoding it by the ordinal encoding, the one-hot encoding, whatever form of encoding, and scaling, if necessary, all this future scaling and the likes, and imputing values for the missing data. For instance, like here that has a missing this thing. The pipeline will have several sessions, one that is handling each session of this and that. And at the end, after converting all of this to all of these values now in the data sets to values that the models can work with and the model understands, it tries to predict what the final outcome will be, which would either be yes or no, or you understand. So the overall concept of a pipeline is pretty, in order to create a pipeline, rather, in machine learning, is pretty straightforward. What you just need to do is you need to create a, you need to import the pipeline first, and you import the pipeline directly by making use of the code here, the from sklearn.pipeline.Pipeline. Just that this pipeline here is the module, while the pipeline here is the class object. Those are the two. That's the way to actually import the pipeline. So I want to just create a simple example here, making use of this model. As I said, in this notebook, I'm not actually trying to do anything precise. I'm just trying to be I'm just trying to like explain or buttress the points of what these functions are actually doing. So we'll say from dot pipeline pipeline. So that's how you actually import a pipeline. But we'll be looking a lot at this specific notebook because it was from here that we actually did all of the process that are responsible for the way the pipeline will operate, the way the pipeline will actually operate. So the first thing we need to do is we need to specify the columns. We need to divide the columns. Now, From our data sets during our early analysis, one of the things we said is that we wanted to drop these two columns. That's the gender column and the married column, future columns now. So once we see these two columns, we want to drop them. So we create a variable for these two columns and we store them into that variable. That is the gender and the married. So we store these two future columns into there. Then there's the continuous future column, the applicant income, the co-applicant income, and the loan amount. We store these three futures, which is this. We can see that they are the categorical listing. And it's easy to confuse the loan amount term with a categorical column. But if we look at it like from a more closer distance, one thing we realize is that it's more categorical in the sense that now there's 360, which is kind of like representing a category with 120, 240. So it's kind of like breaking it in terms of 60s. Because I think if we go down further, we'll see a 60. Yeah, 60, 180. So it's like it's saying 60, 120, 180, 240. Like that's the way it kind of like broke the distance. So it's more of a categorical future column. We place it with the other categorical future columns here. We place it with the other categorical future columns. Now, the pipeline starts with this. This is where the concept of a pipeline actually begins. We create a pipeline for handling the categorical column. And the way we do this is by making use of this this particular making use of the pipeline. Then we say the first thing a continuous data does when it gets here, when it gets the data, it checks for missing value. There's the simple inputter, which I will explain briefly. Okay, I won't run this thing. Okay, so I guess I'll just open the simple. We'll just Google the simple inputter. So that'll be input.simple inputter. So I opened it in a new tab. Oh, beautiful. So what the simple inputter does is that it's an imputation transformer for completing missing values. Now, most of what we've been doing, like before coming here, is that anytime we see a missing value, we kind of infer strategies, making use of the pandas forward filling or making use of the mean values and doing it all with pandas. But sklearn actually provided a tool to do that. And the name of that tool is what we call the simple inputter. And you import the simple inputter by saying the sklearn.impute, which means that there's actually a framework of various forms of imputers now in sklearn. And the way you find all those frameworks is by making use of the impute module now. The simple imputer is just one of them, and as the term suggests, it's a simple form of imputing. And what it majorly needs is the strategy that you need to make your input. And the strategy we want to use for continuous values is anytime we see a continuous value, we want to impute missing values with the mean of that value. And then for the once we've imputed the missing value with the mean, the next thing we want to do is we want to scale every continuous value. We want to scale it, making use of the standard scaler. So this pipeline is configured to process continuous variable by first imputing continuous variable with the mean values, then it scales the continuous variable. Then the categorical variable does something similar as well. It imputes the missing value with the most frequent. I think at one point someone was asking, that was when we initially started that we're talking about data cleaning, and the person was like, can't we fill with the mode? And yeah, initially I didn't get the concept, but what the imputer can do now is it looks at the value that occurs most frequently in every categorical column, and it fills that value with the most frequent. And then It's, as I said, the ordinal encoder is a more universal form of encoding, unlike because it's kind of places an order with them, and it doesn't kind of like breaks the dimension in the sense that like the one-hot encoder, which can encode a binary form of category now into two, making yes and no to appear as a two um, 2 by n, be n by 2 matrix now. It leaves them the same, but placing an order with the value 0, 1, and the like. So this is for the categorical encoder. So this pipeline handles the imputation of the continuous value by imputing the mean value, then standard, apply standard scaling to it. The categorical transformer does something similar, where it imputes the most frequent value, and then it scales it. It applies the ordinal encoder rather to it. Then the data transformer now is where the concept of column transformer comes to play. And the column transformer is different from a pipeline in the sense that a pipeline performs a function of, okay, when the value comes into this pipeline, as I said, it works by a step. When the value first comes in, it first goes through here, then it comes through here, like that. But a column transformer is kind of different, irrespective of the order, all right? What the column transformer does is it makes use of the column and says what would be applied to that column. And most of the columns, if you have noticed, we've defined from this section, where we call the drop column, the category and continuous column, and the categorical column. We've been able to list out the 3 various columns. Now, for the column transformer, you can perform actions like drop and pass through. You can perform actions like dropping and pass through. And I would actually recommend going through some of these documentations for more, in-depth details. But what we are telling this column transformer to do is we'll first give it a name, because at every session, it needs to know the name of what it's doing. It's a list of tuple, if you would have noticed. So this is a list, and within the list, there are several tuples now, 1, 2, 3 tuples. At the first stage, it gives the name of what this transformer or this transforming session will do. The name is the drop code for dropping columns. The action we perform is drop, which can be a string as inferred by the documentation for the column transformer. Then the columns in which it will be dropping, which has been listed here, it will be dropping these 2 columns, the gender and the married future column. Then there's the trans continuous, which means to transform the continuous column. And what the transforming of the continuous column does is that it takes the pipeline now. This is the continuous column pipeline, and it takes every column that has been specified to be a continuous column to pass through this pipeline. So basically, every continuous column that was stated here, these 3 columns, we come to this session. Anyone that is missing will have their value imputed by the mean, and then they will be scaled. The reason why we make use of all continuous columns is, if you could imagine a scenario now where in our training data, there are actually in our training data, let's say there are actually no missing value in the applicant's income, but in the test data, there's a missing value. We want to be sure that we are always able to automatically undo any form of missing data, whether it has been trained or not, all right, provided that the column exists in the model that we hope to produce. So we would have the continuous column now, all of it, both whether it be complete or not, we'll have it to passing through the continuous transformer pipeline. And then we'll do the same thing for the categorical column, where we apply the categorical transformer pipeline, which imputes the most frequent and applies ordinal encoding to it. Now, this is the transformer. By the time we get to this section of the transformer, the columns would have been converted to numeric value, and there will be no missing data at any point of the column. Everything would have been cleaned, like would have been cleaned and pre-processed. So the final pipeline now, which is what we call the loan predictor model pipeline. This is it. It takes just two major things now. It takes the data transformer, which prepares the data. As I said, it does the cleaning and the pre-processing of the data, scaling the continuous data and applying ordinary encoding to the categorical data. So at the end, we have a data like this. Okay. We have a data, something like this. At the end of the column transformer, we have a data like this now. So once it has processed that data to be something like that, would the pipeline would now apply that data to the best estimator from our grid search, because our grid search actually has a estimator, a best estimator, after performing that lengthy process of getting a grid search. And after doing that, what we wanted to do now is we reloaded the data sets compared to what we did in the code cell number 1. We loaded the data sets the way we did, from the start. After loading the data set, we splitted the data set again into the training and test set. And I'm sure that everyone is familiar with all of this stage by now. We splitted the data sets into this. We split it into the training and the testing stage. Then we encoded the target this thing, because if you notice at this stage now, the data set is still raw, in the sense that if you notice there's a missing value here, the NaN stand for the missing value. The gender still has values such as male, married, as no, like that. And this might look like a numeric value as 0 and 1, but the truth about it is that it's actually a string, because if you look at the data sets at some point, that's at the dependent listing, there's such values as 3+, and 3+ cannot exist in this column as an integer. So the data set is actually a listing. The future column rather is actually a string. So all of this stuff would be encoded by the transformer now. And we want to encode the targets, making use of the label encoder, which we transform the Y train and the Y test into values that the model can understand. Instead of it having Y for yes and no, it has value as 1 and 0, something like that. Then our final model, this that was what we did here, the loan prediction model, which is this, which transforms the data and then makes prediction directly. So all of the process that we've been doing since morning was just like the education. This is what we use when we want to deploy the model into production and all of this stuff. We need to have a pipeline, because most of the data that will be entered will not necessarily be cleaned at first sight. So we take that data directly into the loan prediction. So this is it. We now fit the model. And once we fit the model, it does the data transformation and every single thing, and does the training of the model and everything, just with this particular loan predict. And the X train and the Y train are still in their raw form, actually. They are still as this, yes, no, having all of this value, but it does everything, fits the data. And when we predict with the test data, which is still raw as well, we realize that the model still works properly and still has a good accuracy score, good precision score, and a high recall score, like that. So these are the major points that that just needs to be noted, that when you make use of this pipeline, the pipeline is now able to do the transformation. Okay, it's able to do the cleaning, is able to do the encoding, the pre-processing, is able to do the transformation, like taking the whole data set, transforming it into a convenient package that the model can actually understand, and then is able to train the model at the same time. It does all of this with one particular this thing. They are just making use of the fit. So for the let's practice session, okay, I would try I've already started something here, I believe. Okay, so I opened the pipeline, and what we would have to do is we have to redo the loading of the data set. So we want it to be raw, the way it was when we first did this. So we'll be opening the pipeline. That'll be this. So then the data set is still going to be the way it is. Then I want to also redo these steps for splitting the data set rather. And I will split the data set without actually transforming it, like with what we did in our function where we transformed it into values that it can understand. So this particular session, yeah. So if I ask for the extreme dot ed, you realize that the training data, what we want to use and train the model now, is still, a collection of what do I call it now? It's still a collection of data that are not going to be well suitable for the machine learning model, but still doesn't really affect the fact that we will understand it. I've noticed it still has missing values, like the credit history have a missing value and the like. So the first thing we want to do is we want to create a pipeline that imputes the categorical columns. And one of the first things I'll try doing is I would copy this particular column to save time. At least I'll copy this particular cell rather, which tells us the columns to drop, the continuous, the categorical column, and all of that. So just quickly listing them all out here. We have these columns here. So we want to create a pipeline for processing the continuous column. So we'll say the import, from sklearn actually, from sklearn.input import simple inputter. Now, as I've explained, the simple inputter does the process of actually imputing the missing values. Okay, so we want to create a cont. I'll just short type most of this stuff. So cont pipe, which stands for the continuous pipeline, and it takes the pipeline, which is a list of tuple now. And the first thing it does is it takes the name of what the list will do. So I'll call this the inputter because it starts with IM. So we say the simple inputter, and the strategy we want to make use of here is the mean. That's wherever you get this, impute the mean. The next thing we want to do is we want to ask for how it will take. Now we've told it how it will take care of missing values. The next thing we want to do is we want to tell it how it will take care of the encoding of the listing, the pre-processing rather. So we just say the scalar. So the scalar is going to be the standard. Oh, I didn't actually import the standard listing. So I'll just quickly come here and say from sklearn dot pre-processing. So import standard scalar. So the standard scalar is pretty direct. You just have to put in the class itself, standard scalar, and that will do that will handle the continuous listing, the continuous future column, and this is going to be for the categorical future column. Just need to change this to A, and the scalar should be the ordinal encoder, which should be here, ordinal encoder. So that will be By the time we do this, we've already created the pipeline for handling the continuous future columns, and that's for handling the categorical future column. And if we were to keep processing just as we did here, the next thing is to create a column transformer. And I feel this might need to be explicitly written out. So I'll just quickly do this out for sure. So I say from sklearn.compose import the name is column transformer. So the column transformer, just like the pipeline, works by taking these same values that it takes the name, then the the sorry, it takes the name, the estimator, but it also takes sorry, it also takes one thing along with it. It takes the columns that it will be performing the transformation on. So we'll say I'll just call this a transformer. You say okay, that'll be the column transformer, which would take the name. Now we'll just say drop. And what that does is that it takes the term drop. So not to mix up the names, I just make use of drop code. And then the columns I want to drop, that will be the drop columns. Then the pipeline for the continuous variables. Let's see the continuous variables. So we'll say that we want to perform the cont pipeline, but that is the cont pipe, and that will be for the continuous columns. We'll do the same for the categorical columns. So the cat pipe, and that will be the categorical columns. So this is a simple transformer actually, and it does the transformation. And one way we could actually test this transformation, I'll just quickly test it because I don't want us to have, there's still some stuff I want to show you guys. So I'll just quickly show you how the transformer works. I'll just say, okay, transformer dot fit, let's call transform. So the transformer dot fit transform. If you notice, it just works the way you normally do this thing when you fit transform the standard scalar, or you fit transform the ordinary encoder. So just say fit transform. Then you pass in the data you want to transform. And what this does is it returns a value error. Beautiful. Okay, it said could not convert string to float for some reason. Couldn't convert string to float. Where is it actually working from? There is the column transformer. I must have missed something. Okay, there's the categorical pipeline, which takes the continuous pipeline, there's the categorical pipeline, everything. Okay, this is mean. That's the mistake. So it's supposed to be most frequent. I hope I spelled that right. So basically what that does is that it fit transform this X data and it produces a new thing. So I'll just save that into a variable X so that we can just inspect it to see how the future columns look like now. So I would refresh this and I'll ask for the X, which is an NP array now. I will ask for the first row. So it just gives me the first row and we see how the first row looks like. I will say that it's a series of values. If we ask for the length of the X row, so we'll say that's the length of X row, we realize that it's 9. Actually, it's actually 9. And why it is 9 is that we've dropped 2 columns out of 11. And the 2 columns that were dropped is the gender and the married. Then the other columns have been transformed. The first 3 columns represent the the continuous column because it actually applies the transformation in the order in which the values were placed. So the first 3 columns is the continuous column. So we'll see that these values are continuous and they have been skewed. So that's why they look so low. as they are. And then the next sets are the ordinal encoded value. So you see 800011. And it also follows this order, which means the loan amount term comes first, 8, the dependent 0, the education 0, the self-employed 0, which we really don't know what it represents yet, but the credit history, which can either be 0 or 1, and it says 1. Then the property area 1, which can either be 0, 1, or 2. So basically, this transformation is what is now followed up yet, and we know what the predicted model should do. The our final model, which is this. We know what our final model should do. So when this data has been transformed at this particular point of the pipeline, the transformed data is passed to the estimator, which makes the prediction. So that's just an overview of how the pipeline works and what ColumnTransformer is all about, and how all of this stuff are interconnected. So quickly to how this stuff can be deployed. And sorry, before I even go too far, I hope you've gotten what I'm trying to explain. Hello? Yeah, what do you say? You've gotten it right. Okay. Okay. So what we'll do is in order to make use of this model outside of our Jupyter notebook, one way to do that is to serialize the model. And I was actually thinking the reason why I wanted to share this right now, as I said, I wouldn't have time to like break down or the concept of serialization and all of this stuff. But what serialization does is that it takes the Python object now, a Python object, because at the end, what this is an object, and it converts it to a file that can be stored outside of the programming environment, which is our notebook right here. So one would make use of the term pickle, which is a serialization framework. Pickle.dump the pipeline, which is our final pipeline. We dumped it rather into this location, which is the data slash the name of the file .p. The P extension represents the extension for pickle files. And since it's a binary file as well, we make use of the term WB for write binary. So all this line does is that it stores our model outside the notebook. So it is able to store the model in a fashion that we can always load properly when we want to make use of it. So in order to properly test this out, I created a package to help us examine how this stuff works. And I'll upload it probably tomorrow for everyone to be able to practicalize and see how all of this work. But just to give everyone, like to give you a quick overview. Say, so what I'm trying to do now is, since this is working on a web platform, and basically what I built was built on Django. Django is a web building framework. It's a web building framework that can be used to develop websites of any kind. So the goal of what the original intention of making use of Django now is to test our saved model that we made use of the pickle.dump. We made use of this pickle.dump to save into a file as data, which is directly here. We're able to save it directly here. We want to load that model now in a web listing platform and see if it can still make prediction that is outside of our notebook. So if we were to open the URL that is opening it here, and this is like a quick documentation. The thing is, I already uploaded a file, and the way it works is you give the file a name, then you choose the pipeline, which is like the pipeline that will be used for the process. But since I already saved that in the database, I just want to like show you guys how this stuff works. So this is the let me expand it a bit. Yeah. Okay. So this is the like we are trying to predict that same information now, making use of the same making use of the model now, but something that has been serialized that is behind this. And the name of that model is the loan prediction model, directly from what we have here. The loan prediction model, we'll load that particular model and use it to make prediction on the data set, given series of information. So from the test data set, I want to just like pick out some the first information. So that would be the X test. So, okay, you said key error. Let's look for the highest location. So we'll be making use of this particular one to make a prediction on the first data, which should be the outcome should be say the outcome should be yes, Y for yes, which is encoded as one. Yeah, it should be encoded as one. So the Y for yes, yeah. So the first thing we realize is that the gender here is male, the marital status is yes. So I want to quickly impute that into here. So gender male, marital status here. The number of dependents 0, then it's a graduate. The number of dependents 0, then it's a graduate. Is this self-employed? According to here, not self-employed. So we want to switch this particular column to no. So the person is not self-employed. The income that he gets is 9,083. 9,083. So we want to paste that income here. Does it have a co-applicant? No. So the value here is 0. It doesn't have a co-applicant. The loan amount is 228. So we want to impute that 228. Then there's the loan amount then, which is 360, and then the credit history, which is 1. So the loan amount then is 360, and the credit history, which is 1. Then we have the property area, which is the semi-urban. I want to select the semi-urban. I want the model to make a prediction now based on this thing. That's oh, I'm having an error. Okay, it's making a listing for. Sorry, I think I must have mixed up the models here. All right, let me add our new model here then. What will I name this model? I'll just say simple model. Simple model. Then we'll upload our listing. Upload our model directly from where did I stop that? And that data. So this is the model that we are working with. So once I add this model, it has successfully added the model. So I'll come here and I'll select. So it's not selecting more than that. Oh boy. I thought I tested all of this stuff for the program. Sign. Yeah, simple model should be there. Okay, I've known the problem. So, so unfortunately, I don't think. Hmm. Oh boy. Okay, this is what will happen, right? The stuff isn't working as I hoped it would. It's supposed to be generating a list of models that I just uploaded, but definitely, it's definitely not doing that. So what will happen is probably I will just create a separate session explaining all of this work once I have this figured out, because we were supposed to be listing out other models, but it's not, since it's not doing that. I just create a separate video, maybe tomorrow, explaining the session of the serialized model being deployed into web listing, and then how it can be used. I even feel like I've even squeezed it into the time, so it might be hard to understand what I was doing behind this thing. So I think it's actually a good thing, because it gives me time to explain better what was happening behind, what is happening with the serialized model behind the prediction, and how we are making use of it. So I'll just keep this for now, and I think that should be enough for today. If you have any question concerning the pipelines now, that's creating of the pipelines and the column transformer, I'll be glad to hear it, at least before we call it a day.
I have a question.
All right.
Can you hear me?
Yeah, I can hear you.
My question is, why do we need pipeline? Like, what do we need pipeline for?
Yeah, the reason why we need pipeline is that we need a whole framework now, a whole framework that will handle the whole process and do it at once. Now, the thing is, you could make use of functions to do it, right? Like you create a function that will clean the data, then maybe another one that will propose. Sorry, I don't know, my throat is scratching. You create a function that will clean the data. You create another one that will preprocess it, and all of that stuff. Then you create one general function that will perform every step. Now the truth is, this will still work. It will actually still work, and it actually follows the same process that a pipeline aims to achieve, because the purpose of the pipeline and the column transformer is that at the end is able to process your information from this raw stage here to something that a model will understand and immediately act upon. So it fulfills that fundamental step. The advantage of a pipeline is that a pipeline is built to have more robustness, in the sense that a pipeline can actually accommodate many different things at once, and it is faster than when you build a normal function. It is faster than when you build a normal function, because at the end, a Python built function doesn't have of these internal processes, because there are a lot of internal processes that are running behind the scene. When we just called this, and when we just called this, the feed transform, one thing you realize that it's kind of like happened immediately. If you were to make use of a function, you might have to wait a while. Maybe it may not take that long, or maybe with the fact that we have only 614 rows, it might take maybe just few seconds. But if you were now working with, say, a data set as large as 800,000 rows, for that particular kind of data set now, it would take a long while, because it's going to be calling each function one after the other. If there were, say, a for loop within the function, the process will even take longer. But with the pipelines now and the column transformer, they are built-in functionalities that kind of speed up the process and make everything occur at once. And it also has some beautiful features like this drop now, which help us to quickly drop columns that we don't need and to quickly perform transformer. And everything occurs within how many lines? Maybe let's just say all of this. If we were to do it with functions, now it's going to be longer. So that's the reason why we need pipelines. What do you say?
Deployment, model deployment, like to deploy your model, your deployment or something like that.
What are you asking? I really didn't get it. The audio was cracking.
I said deployment, something like that.
Okay, could you like type the question? I'm not really getting you. So if you type it, I will be able to understand. Okay. All right. Yeah, I have like that's what I was trying to explain concerning the model deployment. When I brought this out, I was trying to explain how you could deploy a serialized model on a web platform. As just one example, because there are actually many forms of deploying a model, so many. You can deploy it on Amazon Web Server, you can deploy it on an inference system and all of those stuff. But I was just trying to explain how serialization can be used. Serializing a object can be used to deploy it on a web platform. So in a way, but I can say I haven't actually explained that. What I've explained is how you could create the pipeline and how you could serialize that pipeline, what we did here, all right? How you could serialize the pipeline that was created. So I haven't explained the deployment stage. I said I'll create a video for that and I will upload it tomorrow. I will even share it on the group too. So is that all?
So
Ah. Okay. The pickle is a serialization, this thing is a serialization module. And what that means is that it takes a Python object, Abby, and it forms it to have a form of it converts it to a file, Abby, but a file that kind of holds the integrity of that object in such a way that that particular file can be saved externally from the environment, like what we have here now. This particular object, once I close this notebook, this particular notebook now, this particular object that we have now would become irrelevant or would be destroyed, because at the end of every program, every variable is destroyed. So basically what we have here is a variable, and this variable contains a object, and the name of this object is the pipeline. I'm trying to search for it. Yeah. So this is the object that it contains, this particular variable. It contains this pipeline. And what the pipeline does is that it makes it fits the data and transform it. When we come down to this particular stage, we realize that for that particular pipeline, we were able to fit it. So the pipeline that we have here now have an understanding between the data and the targets. So there is this pipeline, which is still in the variable this. So what the pickle model does is that when we serialize it by making use of the dump, this thing, and I will actually advise that you read more about it, because it will be like what I will say now might not make so much sense till you have your own view of how this stuff works. But what the dump does is that it converts this particular object now, it converts it into a file named this. This is the name of the file that we give it. having the extension .p. So think of it like converting the file into a doc file, like a Microsoft Word file or an Excel file. It converts it into a file, even though it's a binary file, because we are making use of the write binary, WB, to write the file as binary, and it saves it in the location data slash. So this is the file now. Now that I have saved it in the location, this particular file can be loaded outside of this notebook without having to go through the process of creating this and doing this and doing this and doing this. All we just need to do now is to just come and load this particular file directly into our next notebook. Chicken, now everything is done. So that is the purpose of Pickwood. It tries to serialize, and you can read about serialization, but it tries to serialize a Python object outside of the environment that the object was built in. Any question?
Okay, that means when you save Pico, you can just open it with your browser instead of going to Jupyter Notebook.
Exactly. That's what it does.
But this pipeline thing is very broad. Like to understand it is not easy. Like
yeah, I agree.
I was really cracking my head to see if I really understand it very well. But I think maybe I'll browse more on it. It's really broad.
Yeah, but the truth is that it's not that broad though. Once you understand what we've been doing from the start, just think of the pipeline like doing everything at once. And the more you practice, the more you will get it as well.
Okay.
Yeah.
Then you did not teach us all these other forms. Is this our last class?
Yeah, actually it should be. It should be.
Is it? For real. You didn't teach us other model like in nearest neighbors, how to use all those ones, all those other models. How to use support vector machine, all those ones.
It's not as if I cannot teach you, but it's the time. There's no time to teach you guys all those stuff. Plus, if I was to teach you, it would just take more time. The thing is, if you can use one model, but the way we use the random forest, you can always use every other model the same way. They are kind of similar. The thing you just need to know is the difference between them and how to fine-tune them. Once you know that, that's all for the other models. There's nothing really special about them, so to say.
Yeah. What about K-nearest? What's K-nearest all about? I've been hearing of that model.
The K-nearest neighbor is a model that finds the relationship between the position of the data. So basically, what K-nearest neighbor does is that it tries to position the data, say, in various points. Let's say all of the X data is positioned at one side there, all of the Y data is positioned at one side there. So unlike, the linear regression tries to, logistic regression tries to draw a line that separates them, but the K-nearest neighbor tries to tries to cycle them. So it like do a cycle around them. Let me see if I could, let me see if I could. Okay. I always like looking for images. They are one of the best way I've found to explain this, explain model. So let me just say, for instance, this now. What the K-nearest neighbor tries to do, like these two data now that we have this year, the green triangle and the red.
You mean the initial data, right?
Yeah, the initial data. What K-nearest neighbor tries to do is, instead of drawing a line between the two of them, it tries to draw a cycle around class B and another cycle around class A. So is that with this cycle that it used to differentiate them, that it now tries to make a prediction from. And there are more chances that it will be more precise based on the order in which the data is organized. If you realize it's kind of organized in a cyclic pattern as well, if you notice. So basically, that is how K-nearest neighbor does its differentiation. So K-nearest neighbor has the potential to actually scale to more data points. So if they were like maybe class C around here, it will be able to differentiate them very easily compared to how a logistic regression model will do, because a logistic regression model will have to draw a line, but a k-nearest neighbor usually cycles it. So it's a reason why, if you want to, like, for instance, if you want to make, if you want to work on a classification model now for multi-class, a k-nearest neighbor will be better compared to, say, a logistic regression. And it might even be better than a random forest model. So that's what I mean by, if you understand what these models are doing, it will be easy to make use of them.
Okay.
Yeah.
Me, I will still disturb you. I will still tell me with questions later. Because
Okay.
seriously,
Wait.
because all these things.
Sorry, your name. Your name.
Ereta. I'm the
Okay.
one.
You're the one. This the account is different now.
No,
I
it's the
think
same.
in this one it's showing Candy.
Yeah, that's always been Candy.
Okay, that's always the Candy. Yeah.
Yeah.
No problem. No problem.
I'll
Yeah.
still disturb you with questions.
But I hope you were able to share understand this one for tonight.
I understood, but when it got to that pipeline, you know, when you're not understanding something, going to you. So the pipeline was, I was kind of dozing off. I'll come back again, dozing off, come back again. So I was like, I didn't really get the pipeline, but it's all good, Sha.
Yeah. All right.
All good. You tried. Thank you very much.
No problem. You're welcome. And do have a good night rest too. Yeah. All right.